China can now build electric cars with a speed and cost structure that Tesla, Toyota, and Honda cannot ignore. What happens if the most automated, cheapest car factories are no longer in America, Germany, or Japan, but in China? First, China controls huge parts of the battery supply chain. Next, its factories are using more robots, faster assembly lines, and local suppliers clustered nearby. Another reason is government support, which helps companies scale quickly. Finally, fierce domestic competition forces brands to cut costs fast. This is not one machine. It is a manufacturing system, and it could decide who leads the next decade of cars. So why is China's auto manufacturing suddenly so hard to ignore? Because China is no longer just a place where foreign companies assemble cheap products. It has built complete industrial ecosystems around electric vehicles, batteries, software, robotics, factory equipment, and thousands of local suppliers. First, China built massive factory capacity before the global market was fully ready. Cities competed to attract car makers, battery plants, parts suppliers, and research centers. That created industrial zones where a company can design, test, source, and produce parts without waiting months for overseas shipments. Next, local suppliers became stronger. A car company in China can often find battery cells, motors, sensors, screens, castings, and software teams within the same region. That shortens development time and lowers cost. It also means a design change can move from an engineering office to a production line very quickly. Another reason is brutal domestic competition. BYD, Geely, SAIC, NIO, XPeng, and many smaller brands are fighting for the same customers. Prices fall, features improve, and weak models disappear fast. This pressure forces companies to launch better cars at lower prices, sometimes in time frames that older automakers struggle to match. Finally, the best companies learned how to scale. BYD built batteries, chips, motors, and cars under one roof. CATL became a global battery giant. Tesla's Shanghai Gigafactory showed how fast a highly concentrated supply chain could support huge output. Once that model proved itself, the whole industry paid attention. The risk is that fast growth can create overcapacity, thin profits, and quality pressure. But the advantage is clear. China can turn an idea into a finished vehicle with unusual speed. The real shock is not one company's success. It is the system behind it. If this system keeps improving, which global automakers will adapt fast enough to compete? If you found this breakdown useful, like the video, subscribe, and hit the bell for the next chapter. What is actually happening inside these factories that makes competitors nervous? The first layer is the smart factory. In a traditional plant, machines follow fixed instructions, and workers check problems after they appear. In a smart factory, the production line is constantly watching itself. Robots move parts from one station to another. Sensors measure temperature, pressure, alignment, paint thickness, battery conditions, and tiny surface defects. Cameras scan components faster than human inspectors can blink. How does the system catch mistakes early? First, every part gets tracked. A motor, battery module, door panel, or casting can be linked to production data. Next, artificial intelligence looks for patterns. If a weld is slightly off or a battery cell behaves differently, the system can flag the issue before thousands of cars are affected. Another reason this matters is speed. Software can adjust production schedules, redirect parts, and warn managers in real time. Why does robot scale matter? China has become one of the world's largest users of industrial robots. These robots do not only weld car bodies, they handle logistics, inspection, painting, assembly, and battery production. That reduces labor per vehicle and makes factories easier to run around the clock. Companies like BYD, Tesla in Shanghai, and major battery suppliers use high automation to increase output while keeping costs under pressure. What about the car design itself? The manufacturing advantage is not only about robots, it is also about simplifying the vehicle. Large integrated casting can replace many smaller metal parts with one big piece. That means fewer welds, fewer bolts, less labor, and faster assembly. Modular electric vehicle platforms also help because different models can share batteries, motors, electronics, and software systems. When the architecture is simpler, the factory has fewer steps to coordinate. This is why Toyota, Honda, Tesla, and other global automakers are watching closely. The threat is not one machine. It is the combination of automation, data, casting, software, and simplified design working together. But technology alone does not create the full advantage. The bigger question is what happens when these factories connect directly to China's dense supply chain. If parts, materials, engineers, and machines are all nearby, how much faster can the next generation of cars be built? If you want that breakdown, like the video, subscribe, and hit the bell. Why does the battery decide who wins the electric car price war? In most electric vehicles, the battery is often the single most expensive component. It can represent a huge share of the total vehicle cost, depending on the model, chemistry, and pack size. So if one company can reduce battery cost by even a few percent, it can lower the sticker price, protect profit margins, or spend more on technology while rivals struggle to match it. Who gives China that advantage? Two names matter most: CATL and BYD. CATL is one of the largest battery makers in the world, supplying major automakers across China, Europe, and beyond. BYD is different because it builds both batteries and complete vehicles. That means BYD can design the car and the battery system together instead of treating the battery as a separate part bought from someone else. How do these companies lower cost? First, they operate at enormous scale. Large factories buy materials in bulk, spread research costs across millions of units, and improve production through repetition. Next, they push battery chemistry forward. Lithium iron phosphate batteries, often called LFP batteries, are important because they avoid expensive nickel and cobalt. They usually offer lower cost, strong durability, and enough range for many everyday cars. Another reason is supply chain control. Vertical integration simply means controlling more steps of the process. A company may secure minerals, refine materials, make cells, assemble battery packs, install them in vehicles, and support the customer after the sale. Each step gives more control over cost, timing, quality, and shortages. Why does this matter to global automakers? Tesla understands battery cost better than almost anyone, which is why it invests heavily in battery supply and production. But Chinese companies now have a deep local network of cell makers, equipment suppliers, chemical companies, and electric vehicle brands, all pushing prices down together. For Toyota and Honda, the problem is different. Their slower electric vehicle transition means they have less room to absorb a battery price war. If China keeps making batteries cheaper, the pressure does not stop at Tesla. It reaches every automaker still trying to catch up. So if the battery is the heart of the electric car, who controls the heartbeat of the future auto industry? Like the video, subscribe, and hit the bell. Why are Tesla, Toyota, and Honda all watching China so closely? Because China is no longer just a place where cars are assembled. It is a market where electric vehicles are designed, priced, updated, and mass-produced at a speed that forces global companies to react. For Tesla, what is the pressure? First, China is one of Tesla's most important production bases. The Shanghai Gigafactory helps Tesla build vehicles efficiently and export them to other markets. Next, China is also one of Tesla's toughest battlefields. BYD, NIO, XPeng, Li Auto, and other local brands compete aggressively on price, software, range, charging, and interior technology. Another reason is update speed. Chinese brands can refresh models quickly, add new driver assistance features, and launch lower-priced versions before rivals finish a normal product cycle. So Tesla faces pressure from both sides. It uses China's manufacturing strength, but it also competes against the companies that grew inside that same system. What about Toyota? Toyota is still powerful because it dominates hybrids. That matters because hybrids are practical, profitable, and popular in many countries. But the risk is pure electric scaling. If Chinese electric vehicle makers keep lowering costs while improving quality, Toyota may face a market where hybrid strength is not enough. First, buyers compare prices. Next, they compare technology. Finally, governments push more zero-emission rules. If electric vehicles become cheaper and better at the same time, Toyota's slower electric rollout becomes a bigger vulnerability. And Honda? Honda has also recognized the threat. In China, it has been pushing new electric vehicle efforts and investing in highly automated electric vehicle production in Guangzhou. That matters because Honda is not simply waiting. It is trying to respond with faster factories, more localized development, and vehicles built for Chinese consumers. But the bigger message is clear. Japanese automakers are adapting because Chinese competition is no longer limited to low-cost cars. It now includes advanced manufacturing, software, batteries, and rapid product launches. So the pressure on Tesla, Toyota, and Honda is not identical. Tesla is fighting inside China's strongest electric vehicle arena. Toyota must protect its hybrid lead while scaling electric vehicles. Honda is rebuilding its strategy before it falls behind. If global giants now need Chinese-style speed to compete, has the center of automotive innovation already shifted? Like the video, subscribe, and hit the bell. How much of China's electric vehicle boom was planned by the government, and how much came from companies fighting to survive? First, policy created the starting conditions. China used subsidies, tax breaks, license plate benefits, and procurement programs to make electric vehicles easier to buy and easier for companies to sell. In crowded cities, getting a gasoline car license could be expensive or restricted, while electric vehicles often received better treatment. That pushed real consumers toward the market. Next, infrastructure reduced fear. A cheap electric car is not attractive if drivers cannot charge it. So China expanded charging networks, supported battery swapping in some regions, and encouraged cities to build electric vehicle-friendly roads, parking, and power connections. This helped turn electric vehicles from a niche product into a normal option. Another reason was the battery strategy. China supported the full supply chain, from battery materials and refining to cell production and recycling. Companies like Beid grew inside this system, then became global battery giants. When batteries are cheaper and closer to the factory, car makers can lower prices faster. Local governments also competed. Many cities built industrial parks, offered land support, attracted suppliers, and backed local champions. This created clusters where parts makers, software teams, battery firms, and automakers worked near each other. The result was speed, fewer delays, faster testing, and quicker model launches. But government support did not automatically create winners. Many brands failed. Some burned through cash. Others built cars nobody wanted. The survivors had to cut costs, improve quality, upgrade software, and fight brutal price wars. BYD, Geely, Chery, NIO, XPeng, and Li Auto did not grow only because of policy. They grew because competition forced them to become better. So the real answer is not simple. China's rise came from state planning, local incentives, infrastructure, supply chains, private investment, and massive consumer demand working together. But if this competition keeps pushing prices lower, what happens when weaker companies, suppliers, or even global rivals cannot survive the pressure? Like the video, subscribe, and hit the bell. What are the hidden risks when a country builds more cars, batteries, and factories than the market can absorb? First, there is overcapacity. In simple terms, it means too many factories are chasing the same buyers. If 10 companies can produce millions of vehicles, but only a smaller number of customers are ready to buy, those companies start cutting prices to keep production lines moving. That helps consumers in the short term because cars get cheaper, but it also squeezes profit margins, and weaker brands can run out of cash. Why are China's electric vehicle price wars so intense? Because the competition is not only between small startups. Giants like BYD, Geely, Chery, Tesla, and many newer brands are fighting for market share at the same time. When one company lowers prices, others often follow. Next, suppliers feel the pressure. Battery makers, parts companies, software firms, and metal processors may be forced to accept lower prices too. Finally, quality becomes a risk if companies cut too deeply or rush new models too quickly. What happens when China exports this pressure to the world? Other countries begin to worry. Europe has investigated Chinese electric vehicle subsidies. The United States has raised tariffs and added trade restrictions. Governments are asking whether relying too much on Chinese batteries, chips, rare earth processing, or connected vehicle software could create national security risks. For traditional automakers like Toyota, Honda, Volkswagen, and Ford, the concern is not just cheaper cars. It is the possibility that entire supply chains could shift away from them. So China's manufacturing boom is powerful, but it is not risk-free. Overcapacity can destroy profits. Price wars can eliminate weaker players. Quality pressure can damage trust. Geopolitics can block market access. The bigger question is whether these weaknesses slow China down or whether they force the next version of global manufacturing to become faster, cheaper, and more automated than ever before. Like the video, subscribe, and hit the bell. What could this mean for the future of cars worldwide? First, if China keeps building electric vehicles faster and cheaper, global prices could fall sooner than many automakers expected. A lower-cost battery, a more automated factory, or a faster supply chain does not stay local for long. It becomes a new benchmark. Tesla, Toyota, Honda, Volkswagen, Ford, and Hyundai would all face pressure to cut costs, shorten development time, and make electric models more affordable. How might other countries respond? Some will build local battery factories to reduce dependence on China. Others may protect domestic industries with tariffs, subsidy rules, or security reviews. Another path is partnership. A global automaker may use Chinese battery technology, software platforms, or manufacturing methods to catch up faster. Finally, many factories will accelerate automation because competing with low-cost production often means using more robots, better data systems, and fewer slow manual steps. What does this mean for workers? The auto job of the future may look less like traditional assembly and more like managing machines. Workers may need skills in robotics, software, battery chemistry, sensors, and factory data. Countries that train people for these roles could win new investment. Countries that move slowly could lose factories to places with stronger technology ecosystems. So the question is bigger than which company sells the most electric cars. Is China's lead a temporary advantage or the beginning of a new global manufacturing era? If you enjoyed this breakdown, like the video, subscribe, and hit the bell. So, is this the start of a new auto empire? China's edge is not just cheap labor. It is automation, batteries, supply chains, scale, government support, and fierce competition working together. That combination is forcing Tesla, Toyota, Honda, and others to rethink how fast and how cheaply cars can be built. Thanks for watching. Now write your take in the comments. Will legacy automakers catch up, or will China define the next generation of car manufacturing? Like, subscribe, and hit the bell for more clear breakdowns.